Hello students, today we will start our new chapter, Introduction of Trigonometry. Okay, our today's topic is trigonometric ratio. So this trigonometric term is very new to us. So first of all, I'll check when we will use this trigonometric ratio. Okay, and why I am using this type of ratio. Now suppose there is a situation given, a hot air balloon is flying in the air. A girl happened to spot the balloon in the sky and runs to her mother to tell her about it. Her mother rushes out of the house to look at the balloon. Now when the girl had spotted the balloon initially, it was at the point A. Okay. When both the mother and daughter came out to see it, it already travels to the point B. Can you find the altitude of the point B from the ground? Okay, you have to find this distance from the ground. Now, as you can see, you cannot measure this altitude of B in our regular process. Okay, it is in the sky and it is continuous traveling. Okay, I am consider this balloon is traveling through a straight line. Now for this situation, how can you find the altitude? Okay, for this kind of situation, you have to use trigonometry. Okay, now this trigonometry is derived from Greek word. Okay, you can part this trigonometry in three words. First one is tree. Tree means three. Okay, now gon means side, and metron means measure. That means if you combine this trigonometry, you are getting three sides measure. Okay, so the trigonometry is the study of relationship between the sides and the angles of the triangle. Okay, so what is trigonometry? It is the study of relationship between sides and angles of a triangle. Now what is trigonometric ratio? We will discuss today about trigonometric ratio. What is trigonometric ratio? It is ratio of sides of a right angle triangle with respect to its acute angle. Okay, suppose this is a right angle triangle. If this is 90 degree, there is two acute angle, this one and this one, right? So trigonometric ratio is the ratio of the sides with respect to any of this acute angle. So let's check how can you define these ratios. Okay, now first of all, look at this diagram. In this diagram, ABC is a right angle triangle where right angle is at the point B. So as you can see, this AC opposite to this right angle will be hypotenuse, you know that, and I am considering here A as the acute angle. Okay, I am taking the A angle as acute angle. Okay, now this side opposite to A angle will be side opposite to the angle A. Okay, and this AB side, okay, this is the part of angle A. That's why I will name it as side adjacent to angle A. Okay, so here side opposite to angle A, which is BC, and side adjacent to angle A, which is AB, and AC is the hypotenuse. Okay, so remember these terms because we will use it in the next slide. Here there is in this slide we will discuss about 6 trigonometric ratios. So the name of these ratios are sin A, cos A, tan A, cosec A, sec A, cot A. Okay, so now what is the ratio of these trigonometric functions, trigonometric ratios? So as you can see, this diagram and the previous diagram is same, the terms are also same. So sin A, okay, sin A is opposite side by hypotenuse, that is BC by AC. Okay, cos A is adjacent side by hypotenuse, that is AB by AC. Okay, then tan A, tan A is opposite side by adjacent side, that is BC by AB. Okay, done. first 3. Now next 3. First one is cosec A. Cosec A will be hypotenuse by opposite side. Okay. Sec A. Sec A is hypotenuse by adjacent side. Okay. Cot A is adjacent side by the opposite side. Okay. So if you look at these ratios, you can see that this one and this one, these fractions are totally reciprocal to each other, right? Similarly, this one and this one is reciprocal to each other, and this one and this one are reciprocal to each other. Okay, so you can say that this one is reciprocal to each other. So you can say that cosec A is reciprocal of sin A, sec A is reciprocal of cos A, cot A is reciprocal of tan A, or you can write this cosec A is equal to 1 by sin A. Okay, or sec A is equal to 1 by cos A. Okay, and cot A is equals to 1 by tan A. Okay, so this cosec, sec and cot are the reciprocal of sin, cos and tan respectively. Okay, so the ratio defines above are abbreviated as sin A, cos A, tan A, cosec, sec and cot A. Note that the ratio cosec, sec and cot are respectively the reciprocals of the ratio sin A, cos A, tan A, which I have discussed in the previous slide. Now, if you look at tan A was given as BC by AB. Okay, if you check the previous slide, tan A is given as BC by AB. Okay, now this BC by AB can be written as BC by AC by AB by AC, so that this AC can cancel to each other. Now BC by AC is equal to sin A and AB by AC is equal to cos A. So you can write tan A is equal to sin A by cos A. Okay, so here is another property which you have to remember. Tan A is equal to sin A by cos A. Now cot was the reciprocal of tan. Okay, cot was reciprocal of tan. That's why cot A will be cosec A by sin A, the reciprocal of this ratio. Okay, so from here you are getting two properties. One is tan A is equal to sin A by cos A. Now cot A is reciprocal of tan A, so that's why it can be written as 1 by tan A, right? So that's why it is cos A by sin A. Okay, now next slide. Okay, now suppose here in this triangle I am taking acute angle is theta. Okay, as you can see, this is also a right angle triangle, and acute angle is very important. If this one is acute angle theta, that means this side is opposite, this is adjacent, this is hypotenuse, right? So now you will define, in the previous means you have taken acute angle as A, that's why you have evaluated sin A, cos A, tan A, right? Now you have taken acute angle as theta, that's why now the terms called as sin theta, cos theta, tan theta, cot theta, sec theta, cosec theta. Okay, so sin is opposite by hypotenuse. Okay, cos is adjacent by hypotenuse, tan is opposite by adjacent. Okay, cot is the reciprocal of tan, that is adjacent by opposite. Okay, sec is the reciprocal of cos, that is hypotenuse by adjacent, and cosec is reciprocal of sin, that is hypotenuse by opposite. Okay, now suppose there is a picture given ABC triangle where right angle is at the point C. The measurement of BC is 8 cm, AC is 15 cm and AB is 17 cm. So you have to find the trigonometric ratio, 6 trigonometric ratio. So start with sin A. I am here considering A as acute angle. Okay, so sin A will be this opposite side, this is the opposite side by hypotenuse, that's why 8 by 17. Cos A is adjacent side by hypotenuse, that's why 15 by 17. Tan A is opposite by adjacent, that's why 8 by 15. Okay, then sin B. Okay, now for the next three, okay, for the next three I have taken B as acute angle. Okay, now if you consider B as acute angle, then this will be the opposite side, this will be the adjacent side, and hypotenuse will remain same. Okay, now if you want to find sin B, okay, that means opposite side by hypotenuse, so it will become 15 by 17. Cos B, adjacent by hypotenuse, that's why 8 by 17. Tan B, opposite by adjacent, that's why 15 by 8. So as you can see here, look at sin A and sin B, the value is totally different. So that's why the acute angle which you have considered is very important. When you are taking A as acute angle, the value of sin A, and when you are taking B as acute angle, the value of sin B will become totally different. Okay, so here you have to pay your attention whatever you have taken the acute angle. Okay, now we'll discuss about some examples from this trigonometric topic. Okay, trigonometric ratio. The first example is given that tan A is equal to 4 by 3. Okay, find the other trigonometric ratio of the angle A. The ratio of the trigonometric ratio of one function is given, that is tan A. You have to find the ratio of sin A, cos A, cosec A, sec A, and cot A. Okay. Now since tan A is equal to 4 by 3 given, that means you have taken this angle as the acute angle. Okay. Now tan A was defined as opposite side by adjacent side. That means tan A is equal to BC by AB, right? And it is given as 4 by 3. So you can say that, you can consider that BC is equal to 4K and AB is equal to 3K. Why? Here BC by AB is equal to 4 by 3 means you can write BC is to AB is equal to 4 is to 3. So you know that if the ratio is given, you can consider BC as 4K and AB as 3K, right? Now, so this measurement of BC becomes 4K and this one is 3K, and this is a right angle triangle. So by using Pythagoras theorem, you can find what will be the length of AC. So by Pythagoras theorem, AC square is AB square plus BC square. Put the value, it will be 25K square. That means AC will be 5K. So this measurement of AC will become 5K. Okay. Now you have to find sin A. Okay. Sin A was opposite side by hypotenuse, that is BC by AC. So that's why 4K by 5K, so 4 by 5. Okay. Now cos A was adjacent side by hypotenuse, that is 3K by 5K is equal to 3 by 5. Now cot was the reciprocal of tan. So since tan is 4 by 3, that's why cot will be 3 by 4. Okay. Now cosec was reciprocal of sin. Sin is 4 by 5, that is cosec will be 5 by 4. Okay. And sec is reciprocal of cos. Since cos is 3 by 5, cosec sec will be 5 by 3. Okay. In this way you have to solve this kind of question. Now next one, consider the triangle ACB, right angle at the angle C, in which AB is 29, BC is 21 unit, and triangle ABC is equal to theta. Determine the value of cos square theta plus sin square theta and cos square theta minus sin square theta. So as you can see, the value of cos theta and sin theta is not given. So first of all I have to find what will be the value of sin theta and cos theta. Now look at here, in this triangle I have considered the acute angle as theta. Okay. So with respect to this theta, this is the opposite side, okay, and this is the adjacent side, okay. So also in this right angle triangle, the value of hypotenuse, the length of hypotenuse and the length of the base is given. So by using Pythagoras theorem, I will find what will be the length of AC. So AC is equal to root under AB square minus BC square. Why this one? Let me explain. You know that hypotenuse square AB square is equal to AC square plus BC square. Okay, you have to find the value of AC. That means AC square is equal to AB square minus BC square. So that's why AC is equal to root under AB square minus BC square. Okay, that's why I am getting this equation. Okay, so AC is equal to root under AB square minus BC square. In place of AB and BC, put the value. So you will get the value of AC as 20 unit. So this AC value is 20 unit. So first of all, I have to find sin theta. Sin theta was perpendicular by hypotenuse or opposite side by hypotenuse. So it will be 20 by 29. Okay, and cos theta was adjacent by hypotenuse. That's why BC by AB. So 21 by 29. Now you have to find cos square theta plus sin square theta. Put the value in place of cos square theta and sin square theta. You will get the value as 1. Okay. Similarly, if you put the value in cos square theta minus sin square theta, it will be 41 by 841. Okay, in this way we have to solve this one. Now next example. Next example is in a right angle triangle ABC, right angle at B, if tan A is equal to 1, verify that 2 sin A into cos A is equal to 1. Okay, this question and the example number 1 is very similar, right? There tan A was given as 4 by 3, here tan A is given as 1. So you can write tan A is equal to 1. Also tan A is equal to, okay, look at here I have taken acute angle as A, right? This one is acute angle, that means this is the opposite side and this is the adjacent side. Okay, I told you that the acute angle is very important, right? So now if you find what will be tan A will be opposite side by adjacent side, that is BC by AB. So that's why here is BC by AB equal to the values given as 1. 1 can be also written as 1 by 1. So that is the ratio of BC is to AB is equal to 1 is to 1. So I can consider BC and AB as K. Both are K because the ratio is 1 is to 1. So this is K, this is also K. You can find what will be the value of the hypotenuse by using Pythagoras theorem. So by Pythagoras theorem, the value of AC will be K root 2. Okay, so you got this side as K, this one is also K, and this one as K root 2. So now we will find the value of sin A and cos A. Okay, this is the acute angle. So sin A will be opposite by hypotenuse, that is K by K root 2, that is 1 by root 2. Similarly, cos A will be AB, this one by hypotenuse, okay, that is K by K root 2, it is also 1 by root 2. Now if you put the value of sin A and cos A on the left hand side of this equation or LHS, you can find that it will be 2 into 1 by root 2 into 1 by root 2. So this root 2 will be cancelled with this 2. So the value will be 1. Okay. So in this way I can verify this equation. Now we'll discuss about next example. Your question is in triangle OPQ, right angle at the point P, OP is equal to 7 cm and OQ minus PQ is equal to 1 cm. Determine the value of sin Q and cos Q. Okay. So look at here, the value of OP is only given and given that OQ minus PQ. Okay, that means this side minus this side, is equal to 1 centimeter. The value of the sides are not given. So how can you find the value of sin q and cos q? This question is very important. As you can see, this OPQ is a right angle triangle. So by Pythagoras theorem, you can write OQ square is equal to OP square plus PQ square. Okay. Now from the given condition, OQ is equal to OQ minus PQ is equal to 1. Given that OQ minus PQ equal to 1. So from here you can write OQ is equal to 1 plus PQ. Okay, that's why in place of OQ square I am writing 1 plus PQ whole square. Okay, so 1 by PQ whole square is equal to this one. Do use the identity of A plus B whole square in the left hand side. You will get 1 plus PQ square plus 2PQ is equal to this one. As you can see, this PQ square and PQ square will cancel to each other, that is 1 plus 2PQ is equal to OP square. Now OP square, the value of OP is given as 7, so it will become 7 square. Okay, that means 1 plus 2PQ is equal to 49. So 2PQ is become as 48, that's why PQ is equal to 24. Okay, so I am getting PQ is equal to 24. Now put the value in the given condition. Okay, you will get the value of OQ as 1 plus 24, that is 25. So you are getting this one as 24, this one is 25, and this one is 7 given. Now we have to find sin Q. That means the acute angle is Q. So if the acute angle is Q, the opposite side will be this one. Okay, and the adjacent side will be this one. So sin Q will be opposite by hypotenuse, that is 7 by 25. Cos Q will be adjacent by hypotenuse, that's why 24 by 25. Okay, in this way you have to find the value of sin Q, cos Q. Now you can find any trigonometric ratio, sin, cos, tan, sec, sec or cot, any one of them. In this way you have to solve this kind of question. So this is all for today. Thank you.